Davinci Plus is a planned mission for an atmospheric probe to Venus. It lost out to Psyche and Lucy in the 2015 round of proposals for NASA's Discovery program. It was proposed again on 1 July 2019, and shortlisted on 13 February 2020. On 2 June 2021, Davinci Plus was selected and funded by the Discovery program. Davinci Plus will study the chemical composition of Venus's atmosphere during descent. The Davinci Plus probe will travel through the Venus atmosphere, sampling the air, and returning measurements down to the surface. These measurements are important to understanding the origin of the Venus atmosphere, how it has evolved, and how and why it is different from Earth and Mars. Davinci Plus' measurements will reveal the history of water on Venus and the chemical processes at work in the unexplored lower atmosphere before it reaches the surface. The Davinci Plus probe will take the first ever photos of the planet's intriguing ridged terrain to explore its origin and tectonic, volcanic, and weathering history. Davinci was one of the dozens of proposals submitted in 2015 to potentially become mission number 13 of NASA's Discovery program. NASA's planned budget for Discovery mission number 13 is $450 million. On September 30, 2015, it was selected as one of 5 finalists. On January 4, 2017, 2 competing proposals, Lucy and Psyche, defeated Davinci to be selected as the 13th and 14th Discovery missions, respectively. Davinci was revised to Davinci Plus and was again proposed for the Discovery program in 2019 and was selected for phase A funding on February 13, 2020. Its concept study report will be submitted in November 2020. In June 2021, NASA selected Davinci Plus as one of the next Discovery-class missions. The Davinci principal investigator is James B. Garvin of NASA's Goddard Space Flight Center, following 5 orbital missions to Venus focused on remote sensing observations. Davinci Plus will be the first probe since the Soviet Vega probes in 1985 to target Venus's atmosphere. Davinci Plus will directly make measurements in the lower 2/3 of the atmospheric mass. Davinci Plus scientists will explore how Venus's atmosphere formed and then changed over time, including what happened to its water. The findings will help scientists understand why Venus and Earth took such different paths as they matured, and provide another point of comparison for studies of rocky planets in other star systems. Davinci Plus' in situ measurements will answer multiple questions regarding Venus's atmospheric composition as currently formulated for the National Research Council Planetary Science Decadal Surveys Venus in situ Explorer. Davinci Plus is designed to address high-priority NASA decadal science by targeting noble gases, trace gases, and their isotopes, as well as temperature, pressure, winds, and imaging at Venus. Davinci Plus' Venus Analytic Laboratory instruments will provide high-fidelity synergistic measurements throughout the probe's descent, particularly in the upper clouds and the unexplored near-surface environment. VAL design is based on the sample analysis at Mars instrument on the Curiosity rover, which measured the chemical and isotopic composition of the Martian atmosphere, and found the first definitive evidence of organics on Mars. Davinci Plus' 4 science instruments are proposed to be built by NASA's Goddard Space Flight Center. VMS will provide the first comprehensive in situ surveys of noble and trace gases at Venus, and has the capability to discover new gas species in the Venusian atmosphere. VMS is similar to Curiosity's quadrupole mass spectrometer. Proposed to be built by NASA's Jet Propulsion Lab, VTLS will provide the first highly sensitive in situ measurements of targeted trace gases in associated isotope ratios at Venus, addressing key science questions about chemical processes in the upper clouds and the near-surface environment. VTLS is similar to Curiosity's tunable laser spectrometer, proposed to be built by NASA's Goddard Space Flight Center using flight-proven sensors, and led by Ralph Lorenz and Dave Atkinson of the Applied Physics Laboratory and Jet Propulsion Laboratory respectively. VASI will provide measurements of the structure and dynamics of the Venusian atmosphere during entry and descent, providing context for chemistry measurements and enabling reconstruction of the probe's descent. Proposed to be built by Malin Space Science Systems and Mars Hand Lens Imager.